I downloaded this just a little while ago from one of your teammates. I don't know whose. I just clicked randomly. Some of you will have question number 1 in degrees, and some of you will have question number 1 in radians. And the question is, maybe you guys remember there was one very similar to this in your exam. Find 3 angles, 2 positive, 1 negative, that are coterminal with the given angle. So what does that mean, coterminal?
That's the angles are the same.
In the same, perfect, yeah, same direction. So 1 revolution is how many degrees? 360. So if we're in degrees, we would add 360. This is in radians, so 1 revolution is? Yeah, that's all you're doing. So you just take 10 pi over 9, which is the angle they give us, and you're just going to add 2 pi. Now, when you add 2 pi, guys, you see how you have a common denominator of 9, or you have a denominator of 9. So you want a common denominator. It's real easy to get it. Put a 9 on the bottom, and then multiply that 2 by 9. 9 times 2 is 18, and there it is. That's 2 pi. Cool or not cool? And then you just add. What's 18 plus 10? So 28 pi over 9 is one of the angles. Did I do that right? I don't see it here. I don't see, well, maybe that one, maybe that one, maybe that one. So it just eliminates letter A. Let's do it again. So you take the 28 pi over 9, and you're going to go plus 18 pi over 9. Let's see. 28 plus 18, 28, 38, 39, 44, 42, 54, 45, 46. 46 pi over 9. So maybe that one's out, maybe that one. That one's out, maybe that one. Okay, how do I get the negative one?
You subtract 18.
Yeah, you just subtract your 2 pi. Take your 10 pi over 9 and subtract the 18 pi over 9. So 10 minus 18, that's negative 8. Negative 8 pi over 9. And there it is. What do you guys think? What's up, miss?
That's what you do on Thursday, right? Like the final.
For this one? Yes. I think I put initially Wednesday, but I'm going to move it to Thursday. I think I put tomorrow, but we have a PSAT tomorrow. Hopefully you guys got this one right. Where is sine negative and tan negative? Well, sine is negative in quadrant 3 and 4. That's what this means, by the way, where sine is negative. And then where you see tan less than 0, that means where is tan negative. Tan is also negative in quadrant... Oh, nope. In 4. Sorry. In quadrant 3, tan is positive because y divided by x, both are negative. Negative divided by negative is a positive. So quadrant 4. Cool or not cool, guys? All right. Look at this one. Oh no, Chavez, this one looks complicated. X, y denote the point where the terminal side of an angle theta meets a unit circle. If p is in quadrant 2 and x is negative 3/5, evaluate the 6 trig functions of theta. Okay, you're in quadrant 2. So here it is. Quadrant 2. There's my right triangle. My hypotenuse is 1. What did they give me? Sine? Cosine. This is negative 3/5. If you want to do Pythagorean theorem to get that guy, you can. Square root of 1 minus 3/5 negative squared. That's going to be 1 minus 9 over 25. And then turn that 1 into 25 over 25. So 25 over 25 minus 9 over 25. So finally you get square root of 16 over 25. Laws of exponents. Square root of 16 is 4. Square root of 25 is 5. What's up? Did someone say something? Oh, okay. Sorry. That's 4/5. You didn't have to do that if you recognize it's a 3, 4, 5 triangle. But, 3/5, 4/5, 1. And then, yeah, just that's it, guys. First of all, you can always delete answers that are, not cool. That says x is negative 3/5, so that means cosine has to be negative 3/5. So if you don't see cosine negative 3/5, delete it right off the bat. Delete, delete, delete. Oh, that's lame. It's between B and D. So now you just guess. You don't have to guess. The sine is 4/5. So let's see. Sine 4/5, maybe. It looks like it might be B. Sine, nope, it's B. Do you see how we did it, guys? You can check all the others. Yeah, the reciprocal of cosine is secant, so secant should be negative 5/3. Sine is 4/5. The reciprocal of sine is cosecant, so cosecant should be negative 5/4. And yeah, all right. We write the following expression in terms of its reference angle, deciding on the appropriate sign. So 154 degrees is in quadrant 2. This is 154 there. So the reference angle is this guy. So how do I get that? Yeah, what's that? 26 degrees. And then cotangent is x divided by y. So in quadrant 2, cotangent would have been negative. I was hoping you guys would help me out there. So in quadrant 2, cotangent would have been negative. If I use the reference angle, every time you use the reference angle, guys, it's always going to be positive. So because I want it to be a negative, I put a what in the front? A negative. So E. Do you see how we're doing that, guys? See, so it doesn't require much thought. You just got to train your brain a little bit. Rewrite each expression in the reference angle. Okay, so we haven't practiced much reference angles with radians, but I think now is probably a good time to maybe start. I kind of wish it wouldn't. I wish it would have given you a reference or an angle that is not on the unit, like not a perfect unit circle angle. This one is, so you won't have any trouble. 5 pi over 3. What quadrant are you in? 4. You're down here. So what is this angle here? Oh.
1/3 pi thirds.
Yeah, pi over 3, 1/3 pi. So there's your reference angle. So you're gonna be using, let's see, this says to use your reference angle, right? Out, maybe, out. So I think that's kind of lame. It's between those two. Cosecant is the reciprocal of sine. Sine is negative in the 4th quadrant. So you're gonna use letter C. See how we did it, guys?
Wait,
What's up?
why is there a symbol of pi over 3?
What's the what?
Why is it pi over 3?
Oh, because at 5 pi over 3, you're pi over 3 away from being 2 pi. If 5 pi over 3 plus pi over 3 is 6 pi over 3, which is 2 pi. See? You're so close to being a whole revolution. That makes sense? Next question. For the quadrantal angle pi, okay. This is one of those questions that I think they're just trying to trick you guys. Do you know where pi is at? Yeah, you're right here. Give the coordinates of the point where the terminal side of the angle intersects the unit circle. It's negative 1, 0. Now, on the exam, guys, some of you guys got it wrong. I am not blaming you. I think you guys are trying to go too fast. I know you know where negative 1, 0. I know you know that that's the x coordinate, that's the y coordinate. You're just going too fast. So just slow down. Just slow down. Maybe if you have anxiety, if you're one of those that, maybe you should save the unit circle for the last thing, and do something else first. So negative 1, 0, out, maybe, out, maybe. So it's between C and E. And then next, what do they say? Then give the sine and cosecant. Okay, sine of pi is 0 because sine is a y value. And cosecant is the reciprocal of sine. So what's the reciprocal of 0? No, it's not. Yeah, undefined. It doesn't have a reciprocal, guys. So it is C. Cool. This one here, we actually need to talk more about it, but we can already talk the basics about it. So what it wants is, at what angle do I get a negative half for sine? Is it pi over 6? No. It's not undefined. Is it negative pi over 6? Yeah. Yeah. What about 2 pi over 3? No. There it is. And that's it. Okay, this is just the way UH writes it. It means this, guys. Arc cosine of square root of 3 over 2. So cosine of one angle is square root of 3 over 2. No, not pi over 3.
Oh, wait. Cosine.
Pi over 6. And that's it. And I know what some of you are thinking. What about the negative pi over 6? That actually would be a true answer, but we're talking about the terminal branch, and we haven't talked enough about that. So it's the pi over 6 one. And negative pi over 6, that's also the same answer. It is square root of 3 over 2. But the more correct answer is letter B. We'll talk about that when we start talking about inverse trig, when we start talking about graphing. Look at this one, guys. Arctan of negative 1. On the unit circle, you're negative 1 at this location, 3 pi over 4, and at this location, what's that? 4, 8, 7 pi over 4. Now notice both of those answers probably will not be there, yeah. That's because they're doing the whole principal branch thing that we'll talk about. We'll probably talk about that first thing when we come back. What is the answer? E. This is negative pi over 4 right there, if we go clockwise. That makes sense, guys? Okay. Arc sine of square root of 2, that's not possible. Sine is always going to be, or as long as you don't have a number in front of that sign, right? It's always going to be between what and what? Between negative 1 and 1. Square root of 2 is a number bigger than 1. So as soon as you see square root of 2, out. Get it out of there. Cool? Let's see. And then these I think are very simple for you guys. Point of inflection, I would go here, right? I would start right there. Point of inflection on the way down. So point of inflection on the way down, there it is, one complete cycle. So the period of that function, because that's what the question is asking, what's the period, is pi over 2. Pretty basic, guys?
Would that be a negative sign?
Yes, if you wanted to use sine. You could also use cosine if you know that. But yeah, it would be a negative sign. It says find the amplitude on this one. So first I would find the sinusoidal axis. There it is. So the amplitude is the distance from here to the top. So the amplitude is 2. So I think this one's a pretty simple UH quiz, I think. Find the period. You're going to use that half there to help you out. So take the reciprocal of half and multiply by 2 pi. The period should be 2 pi, but you have a half in there. So 2 pi times 2, 4 pi. If you don't like that, you can just go period equals 2 pi divided by the b, which is half, which is also 4 pi. It doesn't matter which way you go, guys. Whichever way you go, you'll get it right. All right, next one, find the amplitude. Now I think they're just like, yeah, I don't know. That's a pretty basic question. Find the period. Again, you're going to use whatever's in front of the x there, pi over 2. So my period should be 2 pi. I'm going to multiply that by the reciprocal of pi over 2, 2 over pi. Pi's cancel out, and you get 4. You guys feel okay? What happened? Where are we at? I thought we were doing so good. Find the amplitude again. 7. Really? That's the last one. Okay. Find the phase shift. Okay, this one tricked a whole bunch of you guys. So this one, finally, we got a good one. There were some of you, a handful of you, that got it right. A lot of you, for this type of question, you said, what's the phase shift with respect to cosine? A lot of you said pi to the right. Does this graph go pi to the right? No. It needs to look like this, guys. F of x equals a cosine b x minus c close plus d. And I have seen, I don't know, I'm kind of sad because subject exams are going away, but I have seen that question on a practice, I can't remember if it was level 1 or level 2 subject exam for SAT, probably level 2, where they did not factor it. They left it at like, oh, what's the phase shift of this? And I thought like, oh, I bet you that question comes out all the time. So what you got to do, guys, you got to factor out pi over 3. So here we go. 3 cosine pi over 3, open parenthesis, x minus, well, when I distribute, I better just get a pi. So then that means I have to have a 3 plus 2. Because 1/3 of pi, when I multiply by 3, that 3 goes away and I just get a pi. Do you guys see that? So there it is. So I just moved 3 to the right. Happy face. Oh, that's one of the worst happy faces ever. All right. Cool or not cool, guys? All right. Find the vertical shift. There it is. -4, 4 down. Nothing crazy there. What do we got here? Given, okay. It looks like it's going to be hard, guys, but it's really not complicated at all. First and foremost, I would look at the amplitude and your C value. So your C value looks like, your D value, the midline. It looks like -1. It looks like -1, right? And then, yeah. And then the distance between -1 and 1 is 2. So I'm going to look for an amplitude of 2 and a -1. Maybe out. So there it is. Look, we didn't even have to determine whether it was sine or cosine. And they're all going to be like that. I don't know why. They're all cosine. They're all going to be like that. Give an equation of the form, blah, 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 which could represent this graph. Okay. So no, they're all sine. Bless you, whoever sneezed. Where's your midline? 1, and then the amplitude? 2. So watch. Out, maybe, out, out. So look, you don't have to do any real, and that's it. Look how fast we went through that, guys. Let me stop the recording.